Hi everyone, this is Shilpa Bhandari. The focus of my project was investigating 4 tree-based machine learning models to find which machine learning model best detects intrusion in a network. The intrusions that we were trying to detect were impersonation, injection, and flooding. An example of one of those intrusions, impersonation to be specific, would be if an adversary sent out an email as the CEO of a company and asked for an immediate fund transfer to the CEO, who is actually an adversary. So this kind of research is crucial for developing intrusion detection systems which allow companies to identify an intrusion on time and reduce the consequences of an attack. So going over the step-by-step process involved in my research, the first step involved in my research was processing the wireless network dataset, known as AWID dataset. When collecting data on wireless network in the real world, getting data that is unrepresentative of the features or has shifted because of location or time changes is not uncommon. The shift in training versus testing datasets due to real-world situation is called covariate shift. A simple solution to the covariate shift is to mix the train and test dataset and generate new training and test dataset based on the merged dataset. In our case, we combine the training and test dataset and use 20% of the merged dataset as the test dataset and 80% of the merged dataset as the training dataset. To solve the large imbalance problem of 10:1 ratio of normal versus intrusive data, we ensure that the number of normal instances in our datasets were equal to the number of instances of attacks. I passed those training and test dataset to 4 tree-based machine learning models: Random Forest, XGBoost, LightGBM, and CatBoost, and evaluated their performance. Then I also conducted a feature analysis using SHapley Additive explanations to understand the importance of wireless network features while a machine learning model is predicting whether a network is intrusive and normal. Going over the results of my experiments, as I mentioned earlier, AWID dataset is not an easy dataset. In the past, researchers have built intrusion detection systems with accuracy of only around 94%, as they did not do a lot of data processing on the AWID dataset. However, since we did heavy data processing, our models were able to achieve accuracy of around 100%. We expected CatBoost to give the best results as the model takes care of missing values for numerical variables, but as shown in table 1, the most accurate model was found to be Random Forest with an accuracy of 99.99%. And looking at the table too, all these models showed their best performance while classifying flooding and showed their worst performance while classifying impersonation in a network. Talking about the feature analysis, we found that the top 3 features shown in figure 3 were the top 3 features used by all 4 models while they were classifying whether a network was intrusive or a normal network. For an example, for classifying injection, the third feature was the most important one, as the third feature had the highest area of blue color. So to sum it up, intrusion detection systems are very important to our society these days. By experiment, we were able to find that the random forest was the most accurate tree-based machine learning model to detect intrusions in wireless networks. While we cannot see a lot of difference in accuracy of these models, with a larger dataset, the differences will start to grow. So by implementing these models on a larger AWID dataset, organization can find which model is the most accurate one in classifying a certain class of intrusion and hence can implement it in the future. Moreover, even though there has not been much work in conducting feature analysis to build a robust intrusion detection system, we were able to reduce the list of features important to these models during wireless network classification from 150 to 15. The knowledge of these important features is going to be important in the future experiments to get rid of insignificant features and to also understand how these models work. In the future, we hope to apply deep learning techniques to intrusion detection. We also hope to apply the ladder method, which is a combination of supervised and unsupervised learning. Thank you so much for listening.